Okay, in this video we're going to build off of the model that we tested in our last video where we were looking at modeling growth curves and time-varying covariates of graduation proportion. In that video, or the last video, or a set of videos, we essentially were looking at the proportion of students graduating from four-year institutions over an 11-year span. And essentially, we were breaking down the variation in grad proportion at three levels. We had the repeated measurement was grad proportion, which is at level 1. We had a level 2 predictor, which was institution, so that's reflected by the ID variable, and then those institutions were nested within different states, and we were using these two variables right here as indicators of the level 2 and level 3 institutions and states. So at any rate, when we ran our basic model, let me see if I can pull it up here. What we found in our last video was that time emerged as a significant positive predictor of graduation proportion. So across institutions and across states, we saw a positive predictive relationship between time, the time one variable that we have right here, and the proportion of students graduating. So over time, we saw that there was significant increases in time, or increases in the proportion of students graduating over the 11-year span. So this was essentially modeled, this was our growth trajectory, the slope for the growth curve that we were essentially modeling right here. And so this variable was our level 1 model variable that was utilized in modeling the growth trajectory. Then we also incorporated the level 1 predictors of tuition and percentage financial aid. So tuition was the percentage of students, the tuition variable was reflecting the tuition rate associated with the institutions, and we saw that that this was tuition levels change over time, and so in turn we're looking at this variable as a time varying covariate of grad proportion, and we see a positive relationship and significant relationship indicating that when tuition rates tended to be higher, we also saw a greater proportion of students graduating. The percentage financial aid was reflecting the percentage of students within a given year who were receiving financial aid within their institutions. And so you can see it emerged as a positive predictor of grad proportion. It was not significant at the conventional 0.05 level, but it was near so. So basically what this is kind of indicating is that when tuition rates were higher and when the percentage of students receiving financial aid were higher, both of those were associated with a greater proportion of students graduating. So in this video, we're kind of moving beyond this, and now we're going to add in level 2 predictors of variation in slopes and intercepts. And so what I mean by that is that in our previous video, we saw that in terms of the level 2 intercepts and slopes for our time factor, we saw that the variances for both of these were statistically significant, which suggests then that we might have between institution characteristics that may help to explain why the institutions were varying in their intercepts and slopes. Keep in mind that the intercepts are reflecting, based on the coding of our variable, where the initial code on our time variable was 0, then what the intercepts are reflecting the institution's initial status when it came to grad proportion. And so we're essentially this variance term right here is reflecting the fact that there's significant variation across the institutions in their initial grad proportion. And by the same token, the fact that we see significant variance with respect to the slopes indicates that that the relationship between time and grad proportion were varying between institutions. So we want to look at potential between institution predictors of those two variance components. So now what we're going to do is we are going to look at adding in the level 2 predictors, math selectivity, or basically institutional selectivity, and percentage of full-time faculty. So these are going to be our level 2 predictor variables within our model. The selectivity variable is computed based on standardized test scores, and you can see that it's already been mean-centered, and percentage of full-time faculty associated with institutions has also been mean-centered. So that's why you have the positive and negative values in these columns. So what we're going to basically address is the question of whether the selectivity of an institution and the percentage of full-time faculty have anything to do with the variation in the institution's initial status with respect to the proportion of students graduating, and also whether these two variables predict variation in the growth trajectory across institutions. So we're going to go to Analyze, Mixed Models, Linear, and we're going to, again, we're just building off of the previous video, and we're going to add in percentage of full-time faculty as a predictor, as well as the selectivity variable. So we'll click on Fixed and move these two variables over. I'm going to go to Build Terms here and move these over. And remember that in the previous illustration, we had already shown that there was variation in terms of the slopes for the time slope between institutions. So we found that there was significant variation there, and also significant variation in the intercepts. And then we also had found that there was significant variation between states when it came to the intercepts as well. But we're not going to focus on that in this particular video. We're just going to look at modeling level 2 predictors of the variation in intercepts and slopes. So given that the slopes were varying across level 2 units, now we're going to build in cross-level interaction terms. So I'm going to click on Build Nested Terms and then click on Math Select and bring it down here and then say by time 1. Okay, and then click Add, and then we're going to do the same thing for percentage full-time faculty. Okay, so now we've got our cross-level interaction that's being computed, or these are the interaction terms that's being included in our model. So now when I just kind of going through, we're leaving everything the same way it was from our previous video, and now we're going to click on OK. And you'll notice that as the model becomes more complex, it takes a little bit longer to process. So you'll see right here that we have our estimates of fixed effects. Again, we have our time growth component, which is at level 1. You can see it's still positive and statistically significant. We see that the level 1 time varying covariates were also positive within the model. So again, basically when tuition rates tended to be higher, we also observed a greater proportion of students graduating. When percentage of students receiving financial aid tended to be higher, there was also a greater proportion of students graduating. So you can see right here, significant, kind of near significant at the 0.05 level. And then we've added in now the level 2 predictors. So right here, you've got the percentage of full-time faculty associated with the institutions, and also the selectivity of the institutions. So those are level 2 predictors. And these are essentially predicting the variation in the initial status in terms of grad proportion across the institutions. And so you can see that both of these coefficients are positive and statistically significant. So in other words, institutions that had a higher percentage of full-time faculty and institutions that tended to be more selective also tended to be those that exhibited a greater proportion of students graduating at the initial time point, or the initial measurement point. So now we have the cross-level interaction. And this is, the cross-level interactions are capturing essentially the variation in slopes, and we're trying to account for the variation in slopes as a function of the level 2 predictor. So hence the cross-level nature of this. And you can see that the cross-level interaction for time one and percent of full-time faculty, that was positive and statistically significant. But the selectivity by time interaction, even though it was positive, it was not significant. So that's not particularly useful in our model. So given given that this coefficient is positive, what this is basically indicating is that the relationship between our time one predictor variable reflecting the slope for our growth curve, it was already positive. So that means that in general we're observing a increase in grad proportion over time. But because this is positive as well, that means that essentially that institutions that exhibited that had higher percentage of full-time faculty, the growth rates tended to be a little bit more substantial. So that's kind of how to think about what's going on in this particular case. So basically the growth rates tended to increase or tended to be larger in institutions that exhibited a greater percentage of full-time faculty. So looking at our estimates of covariance parameters, we see that we still have significant variation in intercepts and slopes across the institutions, and then we also have, across the states, we still have a significant variance component for the intercepts. Basically the initial status across states, that there was still significant variation, so we can include level 3 predictor to account for that. And then also we see that the variation in time, the growth trajectory across states, this is the variance estimate, and you can see it's kind of near significant. I guess you could actually kind of going back to Heck et al.'s discussion about these tests right here, you really ought to be splitting the p-values in half. So it looks like that we do have significant variation in the growth rates between states, and so we might then incorporate cross-level interaction to predict variation in the slopes across states. So that's pretty much what we're going to do in the next video. So hope you find this helpful.